This is an instructional video on the prime factorization, or on finding the prime factorization of a number. Our essential question for today is, how can I tell if a number is written in prime factor form? So our first piece of information is we need to define prime factorization. What is prime factorization? It is when a number is written as the product, remember that means multiply, of its prime factors. Now I'm realizing as I'm writing this that there's one word that we need to make sure that we define, and that's the idea of prime. So I'm going to actually give you two words. I'm going to give you the definition for prime, and then I'm going to give you the definition for its opposite, which is called composite. So what is a prime number? A prime number is a number, a number that can only be divided by 1 and itself. So if I think about all the numbers that multiply to get me that number, the only ones I can think about are 1 and then the number itself. The opposite, as I told you, is what is a composite number. Oops, not numbers, just number. So what is a composite number? A composite number is a number that has 3 or more factors. So I'm going to give you some examples of each of them. An example of a prime number: 2, 3, 5, I'm going to jump a little bit, 13, and the list goes on and on. Now there's some between 5 and 13 as well. Whereas when it comes to composite numbers, 4, 6, 8, 9, and so on and so forth. I want you to pay close attention at what two numbers I did not include in these two lists. Notice how 1 and 0 are not included in these two lists, and that is intentional. So what if we actually put that down? What about 1 and 0? These are neither prime nor composite. Composite. 1 and 0 are kind of those unique numbers in math that are necessary and they hold really phenomenal values, but when it comes to the idea of prime and composite, 1 and 0 don't fit any of those definitions. So let's talk about this. How do I write a number in its prime factorization form? What I tend to use is a factor tree. And I actually had shown you an example of a factor tree back when I did the divisibility rules. And divisibility rules really come in handy. So I'm actually going to put that down too as a hint. Use divisibility rules to help. So let's do an example. So I'm going to think of a smaller number just because I'm looking at my page and I don't have a lot of space left. So I'm going to choose the number 34. Okay. Now 34, I don't think I remember it really from my multiplication charts. I don't really remember it from my multiplication facts. So let's think about our divisibility rules. Now, if you need to, go back and reference your divisibility rules. That's a really good way to use your notebook. It's a resource. Utilize the notes that you have. So let's think. I remember that 2, 5, and 10, I just had to look at the number. So I'm just going to look at that last number, the smallest place value. I see it's a 4. I know that 4 is even. And then I remember with 5 and 10, it had to end in a 0. So, or it had to end in a 5. Well, it's a 4, so it doesn't work there. So I know for sure I can divide it by 2. Now, I'm going to think, okay, 2 times what number gets me 34? And if I have to use a calculator to figure that out, that's perfectly fine. I'm utilizing my resources to find out a piece of missing information. And then I can use a tool correctly and in an accurate place to find the other piece of information. And it's actually 17. Now, let me think about this. I only want prime factors. Is 2 a prime number? Yes, I had defined it earlier as a prime number. How about 17? I want you to think of what numbers multiply to get you 17. I can think of 1 and 17, and I can't think of any others. What I like to do is I like to circle my prime numbers because then I'm reminded that, okay, I don't need to go any further with those numbers. So we've reached our prime factorization. So the prime factorization of 34 is 2 times 17. Now let me give you one that has actually a few more steps to it than just one, because sometimes it's going to happen. Let's go with 24. Now, a lot of you off the top of your head can immediately think, okay, I know a bunch of multiplication facts that get me 24. I'm going to choose 3 and 8. What other options would you have? Well, you could have 2 and 12. You could also have 6 and 4. The nice thing is they're all going to turn out the exact same way. So I'm going to look here. 3. Is this a prime number? Yes. So I'm going to circle it. How about 8? Is 8 a prime number? No. It's composite because it has 3 or more factors. I can list off tons of factors for 8. Not tons, but more than 2, right? So that's saying 2 numbers multiplied to get you 8. 2 times 4. Okay. Do I have any prime numbers here? I have 2. 4 is composite. What 2 numbers multiply to get you 4, 2, and 2? Now, the reason why you don't want to break down and go off and do 1 and 3, because what's going to happen? You're just going to end up with 3 again, and you're going to break it down again to 1, 3, and then 1, 3, and you're just going to end up in a circle, and it's going to be really, really frustrating. So that's why I circle my prime numbers, just so I know that I'm done with that number. Now, I have everything done. I'm going to write my prime factorization of 24. Mathematicians love things in alphabetical order and in numerical order. Since we're all multiplying and multiplication is what we call commutative, I can switch the order and it's not a big deal at all because I always get the same answer, such as 3 times 2 is the same as 2 times 3. But what I'm going to do is I'm going to write it 2 times 2 times 2 times 3, right? Do I have 2? I have 3 2's. Yep, 1, 2, 3, and then 1, 3. Now, another shortened way you can do this is using exponential notation. Notice I'm writing my equal sign because what I'm going to write is going to be the same as 2 times 2 times 2 times 3, and it's going to be the same as getting me 24. We have to be really careful when we write that equal sign, which is why you've noticed that sometimes I draw arrows instead of an equal sign because I really don't want to break the rules of math. Now, I have 1, 2, 3, 2's. I have repeated multiplication, so I can use exponents. So there is another way I can write my prime factorization of 24. And that is how you find the prime factorization of a number.